When we're talking about parallel circuits, we have parallel circuits happen and you have a different path for each current. So you start off, if you have the same three resistors, you have a 10 ohm resistor, and we have a 20 ohm resistor, and we have a 30 ohm resistor. We'll connect that to a battery of 12 volts. And so each path has its own current. So there's a few different things that happen here. We'll still start with step one, where we're figuring out our total resistance. And to do that, we have 1 over our total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and you would just keep going with however many paths that you have. So when we do that here, we take and we say, well, to get our total resistance, 1 over RT will be equal to 1 over 10 ohms plus 1 over 20 ohms plus 1 over 30 ohms. When we do that and calculate that out, we get the number 0.183, and that 3 is repeating. That is not our total resistance. It's 1 over our total resistance. So in order to take, so we have 1 over RT is equal to 0.183, like that. So to get RT, we'll take 1 over this. And the best way to do that is to take and just use the number, the answer button in your calculator. So if I'm calculating this, I'll take 1 divided by 10 plus 1 divided by 20 plus 1 divided by 30, and I'll get that answer. Oh, that is not right. 1 divided by 10 plus 1 divided by 20 plus 1 divided by 30, and I get that answer of that 0.183. And the best way to get the total resistance is to say 1 divided by and press the answer, which will take the answer that you got here, and it'll take 1 divided by that whole thing, and it'll give you that number. So the total resistance for this circuit is going to be 5.45, repeating, we'll just round it off here, ohms. Well, now that's the first part. The second part we want to do is to figure out what is the total current coming out of the battery there. And so to do that, we'll say I is equal to V over R, our total resistance. And so we'll take our 12 volts divided by 5.45. And again, the best way to do this is, now you have this as your answer. So you'll take your 12 volts and you'll say divided by answer, and it'll keep as much of that as possible, and it gives you a nice 2.2 amps there. So that coming out of the battery here, we've got 2.2 amps that then will split, and some of it will go here, some of it will go here, and some of it will go here. Now the thing that happens when you're dealing with a parallel circuit is you have a whole lot of current coming out of here, but the part that splits and comes over here will only, this stuff will only cross here and go back. So the only place that that current can drop voltage is on this single one resistor. Well, when you get back to the battery, you can't have any voltage left. So if you're starting with 12 volts here, you've got 2.2 amps. Some of that splits off, but all of those 12 volts need to be dropped right there. Same thing comes up here. Some of that current comes up here. All of those 12 volts need to be dropped on that one, or all of those 12 volts need to be dropped on that one, because for each resistor, the current that goes through it only touches that resistor. It doesn't cross this one and this one and that one. Some of it crosses this one, but that part that crosses this one only crosses this one, so it drops all 12 volts. Some of it crosses this one, but the part that crosses it only crosses this one and drops 12 volts, and the same thing here. So the third thing that we want to do as we're looking at a parallel circuit is that we want to calculate the current across each path. And so to do that, we use I equals V over R, and we know that all 12 volts need to be dropped on each path regardless of which path it is. So we'll say we've got 12 volts divided by, we'll take the top one up here, we'll say 10 ohms. 12 divided by 10 gives us 1.2 amps. So coming out of the battery, we've got 2.2 amps. 1.2 amps is going to go along this path here. So it'll come here, go down, and it'll meet back up and keep going. Put that better, 1.2. For the next one, we'll take and we'll say I equals V over R. We know that there are 12 volts here, divided by, now we've got 20 ohms on that resistor. 12 volts divided by 20 ohms is going to give us 0.6 amps. And so coming along here, we've got 0.6 amps. So we've got 2.2 amps here, 1.2 goes along this line, 0.6 goes along this line and comes back up. And then the last one that we'll do, I equals V over R. We've got 12 volts divided by 30 ohms. And so we have, when we take 12 divided by 30, we get 0.4 amps. So again, we've got some of that going along this path. We got 0.4 amps here, and we keep on going back. If you take your 1.2 amps plus your 0.6 amps plus your 0.4 amps, and you add those up, you add up with 2.2 amps, which ends up being what you have coming out of the battery. Those 2.2 amps come back together here and go back into the battery. Now, if we're going to calculate our power at the end, which sometimes we'll do, we'll go with power. We'll P equals IV. Well, for the 10 ohm resistor, we've got 1.2 amps times our 12 volts that drop, and that gives us 14.4 watts. If we do that again, P equals IV. This time we have 0.6 amps, and we still have 12 volts, and that gives us 7.2 watts. And then P equals IV equals, in this one we have 0.4 amps. We still have 12 volts that are going to be dropped there, so the power here would equal 4.8 watts. So the things to remember when you're dealing with a circuit that's in parallel are the equation for your total resistance is a little bit goofy. It's all inverted, and so you'll have your 1 over plus 1 over plus 1 over. You'll get a number. You'll take 1 over that number to get your total resistance. When you get your current, that's the current that's coming out of the battery, but it's going to split in 3 different ways if there's 3 different paths. And the biggest thing to remember is that the voltage will be the same across each one. In this case, since there's nothing else that's using up the voltage before it gets to the parallel component, all 12 volts will only drop in each individual component. So 12 volts, 12 volts, 12 volts. And you can use that to calculate the current across each path. So you would have 12 volts divided by the resistance, 12 volts divided by the resistance, and each resistance will result in a different current. Once you have all of your pieces, you'll have your current and your voltage, and you can multiply those in order to get your power.